To begin our journey, we must first enter the forest. It is here that we find a young birdwatcher named Erik. Look, I think I see him now. I think he finally found one. Unfortunately for Erik, he's not the most graceful of birdwatchers, and thus the bird flies away. Nonetheless, Erik tries to chase after the bird, but to no avail. As he rolls down the hill and reaches his landing point, he realizes something fairly unique about the bird's flight pattern. From this spot, he notices that the bird flew along the path of ln of x plus 1. And being the good calculus student that he is, he wants to figure out a Taylor series polynomial for this bird's flight path. Let's review what we know about Taylor series. To start, we'll look at the summation, which is the sigma symbol here. It shows that the summation from n equals 0 to infinity of our function to the nth derivative of a over n factorial times x minus a to the n. This is the base for all Taylor series, and when written out it gives us what is known as the Taylor series polynomial. This shows that when n is 0, your first term is the function of a, added to when n is 1, it is the derivative of your function of a times x minus a to the 1, plus f to the second derivative of a times x minus a squared over n factorial, which in this case is 2. Add that to when n is 3, and you get the function of the third derivative of a times x minus a cubed over 3 factorial, and so on. Now we can put it into context and figure out the flight path of the bird in a Taylor series polynomial. A good first step is to go ahead and list out the derivatives of the first few terms. Let's take a look at what Erik has so far. First, we'll take a look at the derivatives. They show that f prime of x is 1 over x plus 1, f double prime of x is negative 1 over x plus 1 squared, f triple prime of x is 2 over x plus 1 cubed, and f to the fourth prime of x is negative 6 over x plus 1 to the fourth. Now, what Erik is trying to find is the Taylor series polynomial with the notation of p sub n of x when n is equivalent to 4 and a is 0. Next, Erik will find the value of his function and first four derivatives when a is equal to 0. Putting them into a list will make it much simpler to use when finally formulating polynomial. Now we put all this together and formulate our Taylor series polynomial. Now let's take a look at where each term of our polynomial came from. By looking at that second column underneath the function, we see all of our values at a. And now when we look at our general form of the Taylor series, we see that f of a is 0. We plug that in for our first term. F prime of a is 1, and since a is 0, it's x minus 0, so that's 1 times x minus 0. F double prime of a is negative 1, so now it is minus 1 times x minus 0 squared over 2 factorial. F triple prime of a is 2 times x minus a to the third over 3 factorial. And because our fourth derivative of a is negative 6, it will be minus 6 times x minus a to the fourth over 4 factorial. With a little bit of simplifying, we have come to see that our Taylor series polynomial with the notation of p sub n of x is equal to x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4. Wait, what's that, Erik? Yes, I suppose you're correct. P sub n of x is approximately equal to our original function, f of x. We've done it. Thanks for watching, and to all those bird watchers out there, keep looking and stay dry.